The industrial session will now commence. Japanese and English channels are available for each theme of the industrial session. Please select the channel. The first half of the industrial session is as follows. For the theme 1, the hydrogen supply chain, the moderator is McKinsey & Company Senior Partner, Mr. Bernd Heid. And for the theme 2, the regional hydrogen society model, moderator is Fuel Cells Hydrogen Joint Undertaking, Head Unit of Operations and Communication, Ms. Milena Atanasiou. So, I would like to invite the two moderators to speak now.
Are we on?
Mr. Heid, please.
Thank you very much. And thank you for joining our C1 breakout session on hydrogen supply chain in the industrial session. I'm very excited that for the next 45 minutes, I have with me 4 panelists, all from companies that are leading the space of global hydrogen supply chains. So we will have an exciting overview. My name is Bernd Heid. I'm a senior partner at McKinsey & Company. I lead our global hydrogen activities and also lead our partnership to the Hydrogen Council. In fact, I have been part of the group that got the Hydrogen Council started in 2017. So I'm excited to see the momentum all around the globe. I will be the moderator for today's session. And let me start introducing the panelists to you. First of all, I would like to welcome from ENEOS, Mr. Tsutomu Sugimori, Representative Director and Chairman of the Board and Group CEO of ENEOS. Sugimori-san, welcome to the group. ENEOS has been a long-standing leader in the space of oil, gas, and petrochemical production and handling. You connect markets and enable supply chains already today. So we are excited to learn from your experience from hydrogen. Next to that, let me welcome from Kawasaki Heavy Industries, Mr. Yoshinoro Kanehana. You are chairman of the board of Kawasaki Heavy. We know each other a long time from the joint work in Hydrogen Council. So also welcome to the panel here. Under Kanehana-san's leadership, Kawasaki has been exploring international liquefied hydrogen supply chains, including the hallmark pilot project of connecting Australia to Japan via the first liquid hydrogen carrier developed and built by Kawasaki. So I'm excited to hear more from you in the discussion. Next to that, from Air Liquide, let me welcome Erwin Penfornis, Group Vice President for Hydrogen Energy and leading the world business line for hydrogen of Air Liquide. At Air Liquide, hydrogen is not a new molecule for you. You are in this market for decades. You are helping to activate new markets on clean hydrogen and play an important role in establishing liquid hydrogen as a future zero-emission fuel in road transport, marine, or aviation. So also excited to learn more from you, Erwin. And finally, from Petronas, I would like to introduce Mr. Adlan Ahmad, Head of Hydrogen, Gas and New Energy. Petronas is a leading energy player, and you are pivoting in both blue and green hydrogen production and help to introduce Malaysia as a future hydrogen supply hub. So also excited to learn from you. So before we get started, I would like to share as an intro a few perspectives on the overall global market. So if we can pull up the slides, please, I would give a short overview. So first of all, let us have a look at the global investments that we see in the market. On the first page, what we have shown is an overview on global projects in the hydrogen space. As we speak now, we have 350 large-scale projects announced globally. And we keep track of this investment jointly with the Hydrogen Council members. And what you see is that a total of 500 billion US dollars are announced of investment globally. So in order to see the maturity of the projects, we select the subset of what we consider to be mature projects, either FEED investment or post-FID decision. You see that 150 billion out of the 500 can already be considered mature. You see the major hubs, a lot of deployment projects in Asia and Japan, Korea, China, but also in Europe with a whole array of deployment projects, be it in industrial sites, transportation, or infrastructure projects. What you see on this chart is next to the colorful bubbles that you see in the deployment markets, we see the turquoise bubbles, and all of them represent hydrogen giga projects for production. So you see areas with great renewable or blue hydrogen potential in Australia, Middle East, Iberia, or Chile, where we will see future hydrogen projects being deployed. And that is also the driver while we speak today about international supply chains. We have to connect these markets from production to deployment. On the next page, you see an overview on where along the value chain this capital is being deployed. And you see that the majority of this investments, 80%, is happening right now in hydrogen production. And that's both on green, but also on blue hydrogen with carbon capture projects. So clean hydrogen production makes a majority of the investments as of today. And that doesn't come as a surprise. So we see mega scale production in hydrogen in order to enable and activate also the demand and deployment projects. On the right side, you see 128 billion that are being invested in end users, be it fuel cells, be it tanks or components. That applies for mobility, but also industrial users, and also the chemical feedstock. And you see an important link in between. That is also what we will hear more on today. The absolute number is a smaller one, but the importance of connecting the hydrogen production to the end use is very high. And this comes to enabling these markets and linking the future production to the end users. And let me emphasize one more thing. On the left side, you see 120 billion. That is the additional investments that is needed in order to deploy also the hydrogen production. Think of that as investment into renewable power to enable the green hydrogen production as an energy vector. So let's look at the world map on the next page, where we color-coded different areas of the world where we'll see either green or blue hydrogen production at levels of $2 or below. Why the $2? This is the number that we foresee until 2030, and this will also be the cost level of hydrogen production to enable the demand or the deployment project. So therefore, we need cheap and at scale hydrogen production. So on the left side, you see dark green color-coded areas where you see hydrogen production or hydrogen potential for $2 or below. And you see areas in Asia with Australia, China, and India as future hubs. You see Middle East and North Africa, but you also see places in Europe with Iberia where this can be achieved. North America or the US has great renewable potential, so can be self-sufficient as an energy market. But you see also in Latin America, both in Chile and Brazil, potential to produce low-cost hydrogen that is competitive. But we will not see only a world that comprises of green hydrogen. We see a mix of green and blue. And for blue, we will see that in areas where we have low-cost natural gas resources, think of Middle East, North Africa, but also places like Russia or in Southeast Asia with Malaysia and Indonesia, or the US. So in these places, if you add carbon capture and storage projects onto the hydrogen production, that is also where we have an alternative clean source for hydrogen. And where will this all be deployed? That's on the last page that I will share, is where you see all on the next page all of the different end-use applications for hydrogen. So this chart depicts 35 different applications, and the way how to read it, the further right on this chart application is the more cost competitive hydrogen is versus the conventional fuel. Think of hydrogen versus diesel, hydrogen versus natural gas, or other fossil fuel-based power sources. And on the vertical axis, the further north an application is, the better hydrogen is compared to the next best alternative on low carbon fuel. Think of hydrogen versus battery electric or hydrogen versus biofuels on that end. And we see in whole area, and we hear some of that already today, of applications where hydrogen can be in the money, but also is competitive versus the best form to decarbonize. That's heavy duty trucking, that's long distance mobility, trains, but also feedstock, think of fertilizer, steel, or refineries. And the upper left corner has applications where hydrogen is a future fuel. However, we have to understand that this comes at a price. So decarbonization doesn't come for free, and we need an implied carbon taxation or a premium that customers are willing to pay for these various applications. And I would like to pause here and get us started with a discussion to hear from leaders in this space. And let me first get started with Sugimori-san from ENEOS. You are a leader in that space, so excited to hear from you. Over to you, Sugimori-san.
Thank you very much. Thank you very much for your introduction. I would like to introduce ENEOS hydrogen strategy and like to introduce what we are doing concretely. So first, I would like to introduce ENEOS Group 2. ENEOS, it represents Asia, and it is from the upstream to downstream recycling. We are pursuing optimization of global supply chain for 130 years. Oil, natural gas, and other stable supply of these products we have been doing. Now, going forward with the decarbonization, sustainable growth, next generation type of energy supply, in order to do so, CO2-free supply chain or renewable synthetic fuel. So using hydrogen, we are enhancing these activities. And this shows ENEOS' ambition on hydrogen, the roadmap that we have. So from the demonstration phase from about 2025, about tens of thousands of tons of social implementation, and also from 2030 we will start commercialization, and about one half of the supply can be hydrogen from there. So first we will start with our own project, and also phase by phase we will create the supply chains. So there will be industrial use like power, and also in transport as well, we would like to expand demand. So in order to achieve this there are three pillars within our strategy. The first is CO2-free H2 supply chain to build that. The second is to create large-scale hydrogen demand and also new technology development for hydrogen. So let me explain these strategies one by one. The first one is the building the hydrogen supply chain. So we have refining, we have pre-existing assets. We'd like to effectively utilize this. This will be the key. So in the refineries, there are the ports, and there are ports where large tankers can come, and so we will be able to create the supply chain without initial investment. And these are very adjacent to places with high hydrogen demand, so low-cost hydrogen can be secured. And within various options, especially for methyl-hexane, MCH, this for oil industry, this is most reliable, so this is going to be the pillar to creating our supply chain. But on the other hand, liquid hydrogen and other methods, we are doing that as well. So with the advance of technological development and the future trend, we would like to select the optimum carrier. The second option is H2 hub potential for the industries, large scale. This shows our refinery and the surrounding power plants and also steel mills. So in the steel mills, they are in the industrial park, so adjacent there are LNG and other power plants as well. So going forward, there will be a large demand for hydrogen. So we have an advantage in terms of location, and this will contribute greatly to building this hydrogen supply chain. The third strategy is new technology development. With decarbonization or generated by renewable energy, I would like to show you one example. This is hydrogen due to RE plus CO2 in air, so synthetic fuel will be produced. The CO2, without increasing CO2 concentration in air, we will be able to decarbonize. Jet fuel and liquid fuel is indispensable for others, so we will be able to utilize the existing oil distribution network. So this is going to be optimal. And carbon neutral using hydrogen. So we, in the oil industry, will be leading this, and we believe that we will be able to make the biggest contribution. So we will be creating this hydrogen infrastructure.
Thank you for sharing that, and we will have the chance to speak more about it. But let me turn over to Kanehana-san from Kawasaki to also hear from you. Over to you.
So, Mr. Hyde, thank you for your kind introduction. On behalf of myself and Kawasaki Heavy Industries, I'd like to thank my colleagues at ENEOS, Air Liquide, and Petronas, as well as all the organizers and the distinguished guests here today for the opportunity to talk about how we are pioneering the hydrogen revolution by developing all the technologies needed for the establishment of global hydrogen supply chains from production to delivery. Kawasaki is leading a number of liquefied hydrogen supply chain projects, including a flagship hydrogen energy supply chain HESC pilot project between Japan and Australia. Hydrogen's versatility will make it a key part of the global energy transition. It can be produced from various sources in multiple geographies where these sources are abundant. It has applications on both the supply side and demand side of global energy markets, including power generation, transportation, energy storage, clean feedstock for other industries, and many others. Importantly, hydrogen has the potential to replace direct fossil fuels, a major cause of carbon emissions, all the while contributing to global energy resilience. Kawasaki is currently working with our business partners, as well as the assistance of the Japanese, Australian federal, and Victorian governments on the HESC pilot project. The pilot will demonstrate the integration of a full hydrogen supply chain from production in Victoria, Australia, through coal gasification to liquefaction and transportation to Japan via our visionary world-first liquefied hydrogen carrier, the Swiss Frontier. The Swiss Frontier is our technological linchpin that will make global hydrogen supply chains possible and key for our pilot project. As the world's first hydrogen carrier, it will be the blueprint for our commercial scale carriers and will enable the transportation of mass quantities of liquefied hydrogen across open waters. Operational tests have been conducted since 2020, and by the end of this fiscal year, we expect a successful demonstration of hydrogen export between Australia and Japan. In parallel with the HESC pilot project, we are now developing scale-up technologies to be applied for a commercial project. Before the full commercial operation, we need to mitigate potential technical and financial risks for a large-scale integrated supply chain. To do this, we have been awarded support from the Japanese government's Green Innovation Fund, as Japanese Vice Minister Mr. Hirose has introduced earlier, which will allow us to accelerate commercialization. This will be an approximately $2 billion fund, and we will work together with ENEOS, Iwatani Corporation, and our subsidiary company Japan, Suiso Energy, to promote. This project will be one of the front runners to achieve the Japanese government's clean hydrogen supply targets of 420,000 tons per year in 2030, growing to 20 million tons per year in 2050. We are fully focused and committed to develop the necessary hydrogen technology and demonstrate the feasibility of hydrogen commercialization. I'm truly convinced that this industry focus, combined with increasing government policy incentives and harmonized global regulatory settings for hydrogen supply chains, will deliver a new clean hydrogen industry to the world for the benefit of our environment and for the sustainable future of generations to come. Thank you very much.
Thank you. Very exciting to see. So let's turn over to Erwin. Erwin, you explore also liquid hydrogen as a future fuel. Excited to hear more from you.
Thank you, Bernd, and good afternoon, good evening in Japan. Indeed, in this session, I would like to provide a specific focus on the liquid hydrogen value chain, which is becoming and will be more and more a key enabler for the emergence of hydrogen mobility at scale. If we go to the next one, please. I'd like to start just with a few words on Air Liquide. We are a global industrial gas company which has pioneered the development of hydrogen energy over the last 20 years. We are deeply committed to act for a sustainable future and are already engaged into a comprehensive plan towards net zero. We are leveraging both our strong industrial footprint along the full hydrogen supply chain, as well as ambitious technology developments to unlock the full potential of hydrogen. Last but not least, we see collaboration as essential, whether with our peers, whether with governments, in order to deliver on our joint climate goals. And this is the reason why we've created a few years ago the Hydrogen Council, which is today still chaired by our chairman, Benoît Potier, who just offered a speech in the previous ministerial session. We move to the next one, please. As I said initially, liquid hydrogen is bound to become a key fuel for the future of the previous one. Yes, thank you. So liquid hydrogen is bound to become a key fuel for the future of zero-emission transport across sectors. The properties of liquid hydrogen are such that it enables transporting hydrogen more efficiently, as we've seen before with Kanehara-san, delivering it in large quantities with minimum refueling time and minimum footprint on the ground. And last, it also enables storing it in large amount, whether it be in vehicles, in ships, or in aircraft, as you see on this picture. So in a way, liquid hydrogen is solving all the challenges which hydrogen supply chains are otherwise facing. For this reason, we see a massive market potential for liquid hydrogen, which could cover more than 50% of the global hydrogen transport needs by 2050. We're talking here about more than 150 million tons per year of liquid hydrogen by 2050, and already more than 10,000 tons per day by 2030, starting from a global install base of less than 400 tons per day worldwide today. At Air Liquide, we are very actively involved to develop those road, maritime, aviation applications, always through multiple partnerships. That's the only way we can enable such supply chain to emerge. So we're talking about collaboration with OEMs like Airbus, like Daimler, with tier one suppliers like Faurecia, or with other supply chain operators like Equinor or First Element Fuel. If you go to the next one, please. So the potential is huge, as we see, but a number of challenges must be overcome. As a leader in this field, we are today developing new liquefaction technology, as you see on the left picture, aiming for significant scale-up and reduced cost. We're also optimizing liquid storage and trailers and offering breakthrough technologies of delivery stations, allowing to pump liquid hydrogen and deliver it at 700 bar, for example, for vehicles, or in liquid form. Throughout this full supply chain, safety management is, of course, paramount, and we are leading in-depth studies to characterize the specific risk of liquid hydrogen and apply the proper mitigation strategies. So as you see, all in all, technology and industrial know-how will be key to enable the deployment of this sophisticated supply chain. Next one, please. So now the question is, how should we proceed to establish this new supply chain, aiming both for rapid cost and CO2 footprint reductions? So here we are facing once more a kind of chicken and egg dilemma. Liquid hydrogen requires scale to be cost effective, but we can build up this scale if markets are not activated, especially using liquid hydrogen at the beginning. So this challenge is even higher in countries like Japan or Korea, which eventually require hydrogen imports to decarbonize their economy. So in this context, it appears critical to develop a phased approach, as you can see here. And this needs to be built with governments and with the various players in the supply chain. So initiating first the downstream demand and with existing hydrogen sources, that's the only option initially, and then developing local low-carbon liquid hydrogen production to reach a critical size for those markets based on competitive hydrogen supply, and eventually implementing renewable and low-carbon hydrogen imports. If you move to the next slide, we see that with this approach, we can quickly go down the cost curve in the next few years to fully open hydrogen mobility markets across sectors. And we know that cost is essential initially to be able to convert from fossil-based mobility to a zero-emission mobility, while aiming at the same time for a well-controlled trajectory on CO2 footprint reduction, mixing low-carbon hydrogen and progressively more and more renewable hydrogen as it becomes readily available. So as often, this is going to require the right set of policies to ensure that markets and supply chain investment can develop in the right sequence. And I think we've heard extensively in the previous ministerial panel about those different policy efforts that are being developed by government. So this is the reason why we see a lot of value in this hydrogen energy ministerial in order to share and align visions from governments and companies. So I thank you very much for the attention, and I hand it over to you, Bernd.
Thank you, Erwin. Very exciting. And let us hear from our fourth panelist from Adlan Ahmad on his perspective on future energy markets. So Adlan, over to you.
Thank you. Thank you very much, Mr. Chairman. My fellow panelists, it is indeed an honor to be on the panel with you. Please allow me a few moments to share a little bit about my organization, Petronas, and what we are doing in hydrogen. Is the organizer going to share the slide, or if not, no problem. I will try to find my slides on my computer. Yes, do you see it now? Thank you. So maybe I can proceed. Oh. Okay. Next slide, please. Thank you. Petronas is the national oil company of Malaysia, and we were formed in 1974. And I think we were among the first movers in the LNG market way back in the early 80s. And we went through the initial struggle of putting the supply chain together. And through collaboration with many partners, we managed to get the business going way back then. In 2019, because of the energy transition, Petronas has come up with a new statement of purpose, which is a progressive energy and solutions partner enriching lives for a sustainable future. And our venture into the hydrogen business is actually aligned with our statement of purpose, which is to provide our customers with clean energy. Next slide, please. Yeah, so as you know, Petronas is a fully integrated oil and gas company. We've got from upstream to gas and new energy, downstream, as well as project delivery and technology. So in November of 2020, we formed our hydrogen unit under gas and new energy. So the gas and new energy division is actually the one-stop center for our customers when it comes to new energy. So our hydrogen group works together with our upstream division for carbon capture, storage, and utilization services. We work together with our downstream division for storage and transportation, especially when it comes to in the form of ammonia, because we are also big ammonia exporters in Asia. And of course, we look to our project delivery and technology division for engineering, construction, as well as research and development for hydrogen. Next slide, please. So for our move into hydrogen, we will be producing both blue and green hydrogen. For blue hydrogen, we will be leveraging on our facilities in Peninsular Malaysia, where we already have an existing ammonia plant, and that can be leveraged for the purposes of blue hydrogen export from this region. For green hydrogen, we will utilize hydropower as well as solar and wind, of course. And we will be collaborating with the suppliers of renewable energy, both on the peninsular side as well as on the Borneo side. So, and as far as transportation is concerned, because we are already big ammonia players, we are of course looking forward to continue to use that medium as a transportation for hydrogen. But we are also exploring new modes of transportation of hydrogen, such as liquid organic carrier. Yeah. Next slide, please. So that's the end of my presentation. It's quite brief, and like I said, I'm very honored to be part of this panel, and look forward to learning more from the wise gentleman here so that we can further this business. Thank you very much.
Thank you, Adlan. Very exciting to see your activities. So maybe we have some time left for a short discussion in this group. So let me turn to Sugimori-san from ENEOS. I'm very excited to see your presentation and discussion. So keeping in mind to connect international and domestic markets, what do you think are the key success criteria to make that happen?
The Japanese government declared carbon neutral 2050 and 20 million tons of hydrogen. So this is about 10% of the primary energy source in Japan. For our people's lives and economic societies, in order to become energy source, there needs to be 3E plus S. So safety and efficiency and environment, all of these need to be well balanced. In order to make that possible, there has to be a supply chain where hydrogen in large volume can be distributed at low cost. So we need to look at demand as well and also supply hydrogen that way. The renewable energy potential, we will be looking at this, but from the viewpoint of cost and volume, we believe that the overseas renewables is more competitive, so we need to supply diverse renewables from overseas. Currently in our company, with Malaysia, Petronas, and others, Saudi Arabia, Australia, we have collaborations with many companies in those areas so that we will be able to secure a diverse supply source. Thank you.
Thank you very much. Let me turn to Kanahana-san. Also learning from you, it's exciting to see that we actually are able for the first time to ship liquid hydrogen as a new energy source around the world. What do you think are the key success factors to get this global supply chain going?
Okay. Yeah, we are keen to successfully run our pilot operations and then establish a commercial hydrogen supply chain. Supportive and coordinated government policies continue to be fundamental. The focus now is on continuing to reduce cost through large-scale deployment of hydrogen and developing demand. To do so, investors, industry, and policymakers must work together. We are now working to scale up facilities over the next few years through commercialization demonstration projects to maximize the potential for full commercial operations in the 2030s and mitigate potential financial and technical risks as we increase scale. As mentioned, we have been awarded support from the government's Green Innovation Fund, which will allow us to accelerate commercialization activities to be conducted. The substantive contribution to the Green Innovation Fund, combined with equally sizable private sector investment, is a gold standard example of how government and business can work together to address early industry development of barriers and facilitate the integration of hydrogen in a new carbon-free global energy economy. Besides financial investment into hydrogen development, industry still needs ambitious and clear carbon reduction policies from regulators that will substantially incentivize low-emission technology and increase its competitiveness compared to carbon-intensive, cheaper alternatives. Thank you. Continue.
Thank you.
Finally, a global harmonized and technology neutral definition of clean hydrogen is very important to accelerate the establishment of thriving hydrogen industry, avoiding carbon leakage. We need consistent, simple, transparent, and government-backed international standards that take into account the entire range of carbon reduction technologies available for the production and utilization of hydrogen. Thank you very much.
Absolutely great. Thank you very much. So, Erwin, over to you. I think it's important to also activate these markets. A lot of that has to do with the chicken egg dilemma. What's your view on the coupling of production and supply and how to and demand and how to get that activated? And maybe let me follow up on Kanahana-san's point on the clean hydrogen. What is your view, maybe shortly, on the standards, knowing that there are different interests in the industry, but maybe if you can also shortly comment on that one.
Yes, for sure. Thank you very much, Bernd, for the question. So you're raising actually something which is quite fundamental, which is what should be the most effective policies to be able to activate indeed those zero-emission markets, especially in transport, where we see a quite complex value chain to be able to enable. Air Liquide being present in quite a number of countries, we've seen over the last few years quite a number of initiatives from governments, and we're very thankful for this. This has allowed to initiate hydrogen mobility in a number of countries. But it's fair to say today that some are working much better than others when we look at the result a few years later. So if we look a bit at some best practices, I think the first one that comes to mind is the fact that especially with transport sector, in order to activate, the first focus of government policies should go towards infrastructure build-up and reduction of the hydrogen supply cost to those mobility sector before getting into the supply of low carbon and renewable hydrogen. Not saying that the second is not important, but when we see some countries which are requiring initially 100% from the get-go to activate 100% renewable, or low carbon to activate those mobility markets, this make it actually impossible to be able to reach the target cost, with also the risk of delaying the entire activation, just for example, for the time of building up those new capacities. And if we go one step beyond, actually it even sends a wrong signal to the entire ecosystem and to government, because it doesn't properly valorize the true economical potential of hydrogen. So that's an important point. Another important best practice is that when you shape policies, especially for a sector like mobility, you should address the upstream and the downstream sectors, and simultaneously. So of course, we're talking about different instruments in order to get this supply push on one side and a demand pull. But if you don't play with them really simultaneously, you end up actually delaying the overall activation. And it's interesting when we look at global scale, it's fair to say that probably these days in Europe, the supply side is very much focused with quite effective systems like RED II directives, while on the downstream side, it's more difficult, and Asia is enjoying the opposite. So I'll close on this one. Just very quickly on your second topic, Bernd, which is about the need for an international framework. I will not, for the sustainability attributes of hydrogen, I will not get back to it. I think Kanehana-san said it very well. That's a key enabler to be able to trigger the first large-scale investments. We've heard many governments today saying that yes, it is critical. So now I think the topic is how we go there. And we've seen a number of initiatives in the last few years. The Certify project backed by the European Commission in Europe is a very strong example. And I think now as the Hydrogen Council especially, and with the members of the Council, we are looking forward to support the build-up of this standard framework, because we need to have this urgently ready in order to launch all those investments.
Arvin, and I know that we are running out of time, so therefore just a short question over to Adlan. Adlan, what is your view going forward, and how do we bring these plans and you into action?
Yes, there's so many moving parts, right? But I think the main one here is there needs to be collaboration between the buyers and the sellers. Not the traditional relationship, but just to get the trade flow going. Hydrogen today is still very expensive to produce. And I think expectation of getting low price hydrogen today is not very realistic. So there must be a balance in there somewhere in order to make it happen. And there is probably a need for some long-term volume commitment to de-risk some of these projects so that they can be bankable and it can be taken off the ground. So, I mean, there's still a lot of things to fix, I understand, but that's what we need at the moment to get these projects going, just to kick off the supply chain. Thank you.
Thank you very much. And it feels like we could go on at least for another hour, but I'm afraid we came to an end of this session. If I take one thing from all the examples that you shared, hydrogen is number one, not just a short-term phenomenon that's here to stay and will continue to stay with us over the next decades as a new form of energy transport. And the second thing that that became very, very clear is we cannot do that alone. Each of you spoke in your contribution of the partnerships and the ecosystem. So I truly believe that we have with hydrogen a vector that can only be tackled not only in an ecosystem on the private sector side, but you mentioned often also the public side. So I think we all need to pull in one direction to get it going. This is different than in other parts of the business ecosystem that we see. So therefore, thank you very much. I feel honored that I had the chance to have been moderating such an esteemed group of leaders in this field. And thank you very much for your contributions today.
Yep. Thank you very much.
Thank you, moderator. Sir.
Bye-bye.
We will now like to resume. Japanese and English channels are available for each theme of the civil session. Please select the channels. The second half of the industrial session is as follows. First of all, the theme 3 is a fuel cell module. Moderator, New Energy and Industrial Technology Development Organization, Mr. Eiji Ohira. And for theme 4, water electrolysis, moderator is United States Department of Energy Fuel Cell Technology Office Manager, Dr. Sunita Satyapal. So now, I'd like to invite the two moderators to speak.
So thank you very much. We'd like to start theme 3, the fuel cell module. Thank you very much for your participation. Now, concerning fuel cell module, this can promote hydrogen use in wide areas and lead to decarbonization. So it is a key device. And in order to expand this further, there are challenges and also actions that need to be taken. These have to be clarified. So this is today's topic. So we have invited 5 people who are leading these areas. So first, we'd like to ask all of you to introduce yourselves and briefly explain what you are doing. So first, Plug Power CTO, Mr. Tim Cortez.
Thank you very much. Good morning, good afternoon, and good evening, depending on where you are today. I'm going to share a few slides real quick, go through Plug Power. So Plug Power has been around for about 24 years. We're a global leader in hydrogen and hydrogen fuel cells. We've actually deployed probably over 45,000 fuel cell systems to date. We're one of the largest users of liquid hydrogen in the United States. We use about 40 tons a day. We've got our headquarters is in Latham, New York, and we've got about 1,650 employees. So we really created a hydrogen ecosystem within the material handling application, so forklifts, pallet jacks. And what we really have done is provided an end-to-end solution where we supply hydrogen, we dispense it, and we also provide the fuel cells, including the service for those fuel cells. So in last year during the pandemic, 30% of all the groceries that were shipped within the United States were touched by a forklift or a pallet jack that was powered by a Plug Power fuel cell. And our customers demand 24/7 operation. So if we think about going forward in the future for fuel cells, we're developing some OEM platforms that will allow us to address multiple markets, including mobility and stationary applications.
Please turn the display settings. Can you click the display settings? Mr. Curtis?
Sure. Is that better?
Okay, thank you very much.
Sure. So we're developing our fuel cell zero emission platform for fuel cells to be able to address multiple markets, including the mobility and stationary applications. And the modular platform will allow us with a handful of units to be able to touch multiple applications, and will allow for easy access and integration with OEMs. In addition to fuel cells, we're really confident that, and we're really positive about the fact that we really need a complete end-to-end solution, including hydrogen solutions. So we've done some acquisitions over the last couple of years, including an acquisition of an electrolysis company as well as a hydrogen liquefaction company. Those are really going to allow us to grow, again, from that end-to-end solution standpoint. And if we look at what our plans are for the future, in addition to the already over 125 refueling stations that we have in place in the United States, we've identified 6 facilities that we will be building for generation of green hydrogen, liquefaction and distribution. And over the next few years, by 2025, we plan to have 500 tons available of liquid hydrogen. And by 2028, our plans to grow that to 1,000 tons per day. We're also expanding globally. We've got partnerships and joint ventures that are being worked on right now. We have a joint venture with Renault on the transportation, hydrogen generation, and distribution standpoint. We're working on a joint venture, and we've received a large investment in Plug Power from SK in South Korea, and that's also for the power generation and liquefaction standpoint. And we're also working with Acciona in the Iberian Peninsula on their generation of hydrogen with their renewables and liquefaction from our standpoint. Scale up is really important. So we think about how do we scale up fuel cells. So we're building our first PEM gigafactory and innovation center in Western New York, in Rochester, New York. And that facility will allow us to build 7 million MEAs per year, 7 million bipolar plates, and 60,000 fuel cell systems, in addition to electrolyzer systems that we are going to be building at that facility. This gigafactory will be able to be replicated in other parts of the country and other parts of the world. So we plan to have this facility up and running, the start of production by the end of this year and full production by the middle of next year. So Plug's view is we are weaning the world from fossil fuels for different applications, drones, UAVs, small robotics, airport GSE equipment, also the mobility, but also large stationary as well as marine applications. And one of the things that we truly believe, and I think this was said in the previous session when we were looking at the hydrogen supply chain, but we really believe that in order to scale up applications for fuel cells, that it really takes a concerted effort between private sector, public in terms of government regulations and funding, as well as R&D and innovation. So I appreciate your time and look forward to the continued discussions of the panel. Thank you very much.
Tim-san, thank you very much. Next, from PowerCell CEO, Mr. Richard Berkman, please.
Thank you very much. Thank you very much for hosting us. And let me just share my presentation here. Is it visible for you? Very good, then. Once again, thank you very much for hosting us and allowing PowerCell Sweden to participate in this very important event that you're hosting in Japan today. Short background to PowerCell as a company. We also claim to be a leading fuel cell technology company. We have been doing research and development in this area for over 25 years, almost 28 actually right now. But we have an extensive IP portfolio that we now leverage to industrialize and also to participate in scaling up, as was mentioned by Plug Power, our colleagues. Started out as a spin-out from the Volvo Group in 2009 and also listed on the NASDAQ. We have a headquarters in Sweden, but we have a global presence by ourselves in different areas of the world, in China, Norway, and Germany, but specifically through partnerships. We need to have, as many pointed out in these previous presentations, in order for us to scale up and be able to deliver the value that is in the hydrogen economy, we need to have partnerships. And our collaborations with Bosch, Hitachi ABB, Siemens Energy are really, really important to us. And for the more local presence in Japan, we have very fruitful partnerships with Inabata and Toray, bringing extensive knowledge, not only about the chemistry and the technology inside the fuel cell and fuel cell value chain, but also to the specific Japanese market, who is leading to a large extent globally when it comes to adaptation to the new technology. We claim and we drive towards true zero emission energy solutions. We have a leading technology through our partnerships and through our extensive IP development. We have stacks who have superior energy density, which is also scalable in size, and it's also been industrialized together with major OEMs in the automotive industry. The partnership we have with Robin Bosch GmbH is also optimized on the on-road market, but we also get the benefit from the joint industrialization, giving us access to a supply chain and manufacturing, which give us industrial stability with everything from cost reductions to quality and performance. We have a core technology based on a 100 kilowatt system, which can be installed vertically, horizontally, and adapted into specific segments with different applications. We use it today in commercial applications for marine, stationary, and off-road customers. We have then, as I said, extensive expertise and experience from the research and development done by PowerCell for many, many years. We are already in a gigafactory, although we don't have the demand for the moment. But the manufacturing capacity is about 1 gigawatt when it comes to fuel cell capacity. We say that in the stage that we see right now in the industry, where we are going from exploratory technology development to a more industrialized and a scaling, as we mentioned before, we see that our contribution is to use an industrialized product portfolio, industrialized technology, but offer adaptation very close to the customer application in our specific segments. By doing that, we support the transitions towards zero emission solutions, and we minimize technical risk, minimize R&D investment, and minimize time to market, which is essential because any technology shift is something that is going to be a burden for the different actors in the value chain. We have a scalable product portfolio ranging from a 5 kilowatt solution up to a 200 kilowatt system, which can then, of course, be optimized in different sizes and solutions depending on the segment. And here we see some of the addressable markets that we have, the off-road segments, where we have products and solutions from 30 kilowatts up to 3.2 megawatts. For the marine and stationary segments, we go even higher to multi-megawatt installations. And this is a contribution that we give to the market where we use industrialized products and do adaptations for the customer. That is what we call industrialized innovation. We continue to be innovative, but we need to do that based on something that is industrialized to give stability to the customer in this transition. So what we think is important, this taps into what was mentioned by Mr. Cortez from Plug Power. We need to scale up this industry now because it is time to act right now. And we think that it's extremely important for us to contribute from PowerCell and our colleagues in the industry, but also equally important to collaborate with authorities and industrial collaboration because we need to have a broad implementation for large-scale industrial pilots. That's the only way to build necessary domain knowledge and end-user experience. That will then drive the know-how for policymaking, regulation, best practice standard, etc. So we all need to contribute to accelerate this emerging hydrogen economy and the transition towards zero-emission energy solutions. So thank you very much for listening. Find us and keep in touch, and we are around for questions and answers afterwards. Thank you very much.
Thank you very much. So Refire Group, Ms. Audrey Ma, please.
Can you see my screen now?
Yes.
Okay, I guess this is the time to start. Good morning, good afternoon, and good evening to all the fellow practitioners of hydrogen and fuel cell online right now. Thank you very much for the Japanese government. Thank you, Meti and Neto, for this incredible opportunity for Refire to be sharing some of our discoveries of this industry with all the honorable panelists as well as the guests online at this moment. So here's a little bit about who we are. Like Power Solutions and Plug Power, we are dedicating ourselves in developing fuel cell technologies to promote the usage of hydrogen as an alternative fuel for a cleaner planet. So we, Refire, we were founded in 2015, much younger than many of the practitioners here today. But likewise, we had the vision of commercializing fuel cell technologies, and we're committed to building a better hydrogen ecosystems with global partners and partnerships. So in the past 6 years of our existence, we have grew from a team of engineers to a global team of 600 people, current employees, throughout a couple locations in China, as well as the R&D center in Vancouver. Here on this map that you can see our headquarters being in Shanghai, and here's a photo of our Shanghai's headquarters with one of the utmost equipped laboratories in China for stack, fuel cell systems, components, R&D, testing, verifications, and validation. We have a few factories producing both stacks as well as fuel cell systems. Here is our latest opening of a fuel cell system factory in Changshu, which is 1 hour away from Shanghai, commissioned last year to producing mid to high power fuel cell systems at the moment. Our first factory opened in Yunfu, now having produced a few thousand of fuel cell systems today, and now a Foshan factory opened to produce stacks. So in terms of figures, where we stand today in promoting this fuel cell technology and deployment, we have delivered more than 3,200 systems to our partners, and most of those are vehicle OEM partners. And over 2,700 fuel cell vehicles have been deployed in cities for daily operations. Total accrued mileage driven so far have surpassed 80,000 kilometers to date, and we have contributed to curbing the roadside pollution of more than 40,000 tons of CO2. So just as we are headquartered out of Shanghai, given a figure out of China market, we account for about 40% of all the fuel cell electric vehicles operating in China. In addition, with partnerships, we have also been adopted our programs, and our systems have been adopted for programs in US, Japan, Germany, Switzerland, and Malaysia. So here's a map to show you more visually how the programs have been deployed. And this is a testimony to the deployment rate and the scaling up effect that Refire is contributing from where we are humbling to the society, to the industry at large. So in 17 cities in China, we have programs in moderate to high moderate volumes that have been using the fuel cell systems in vehicles powered by Refire, and also in a few countries other than China, where programs have been deployed. So we are a fuel cell system and component designer, engineers, and manufacturers. Out of the Refire group, we have Refire Technology, which is focusing on the fuel cell systems design and production. There are also two subsidiaries that are now focusing on stack development, stack and MEA development out of Unilia fuel cells, as well as power electronics for fuel cell systems, and which is carried out by a subsidiary called Pondo Electric. So all together with these three parts, we contribute to a fully integrated fuel cell systems that can be delivered to our OEM customers and ready for installation at the powertrain level. So in terms of a little bit about the market outreach here, in China, like said, the vehicles using our technologies have been deployed in 17 cities in China, and these are some of the cases that have been put on the road service in the past couple of years. Selected customers for these fleets of trucks that have been serving, including JD.com, the second largest e-commerce platform in China, STO Express, one of the largest delivery parcels companies in China, as well as Budweiser in the Shanghai region for their testing of delivering beers. For the bus fleets, there are also close to about 1,000 buses that are now using the systems with the fuel cell technologies inside throughout the country. Moving forward, we're looking at heavy-duty truck applications, and these are some of the prototype vehicles that we have helped our OEM partners to complete, again, with fuel cell technologies that we provide to them. And these vehicles will be adopted in the 4 following scenarios, low speed enclosed areas, such as for port, for factories operations, for road freight transport, both intercity and long haul, and for municipal utility usage. For example, here we have a 31-ton concrete truck, and we have now here an 18-ton water truck for the city's utility service, as well as construction services and so on and so forth. International collaboration is key for Refired in the past couple of years, and here are some of the projects to note. Both in China and internationally, we pay great heed to the international collaborations and the partnership that we have built so far. So here are 2 examples that we have joined forth with Toyota Fuel Cell Technologies and having deployed in China. One is a bus program that have been put into service in January of 2020. This is a collaboration using some of the Toyota fuel cell technology, including stack, as well as balance of plant component, and Refired integrated the Toyota technologies into a fully functioning systems for the commercial vehicles. In this case, we have adopted this product for a fleet of buses in the city called Changshu. Since deployment over about a year and a half ago, this fleet of buses have been driven for more than 1.5 million kilometers as of September of this year. Another program with Toyota, again, is a 31-ton logistic truck deployed in May to service Toyota Suzhou's delivery service in the Yangtze River Delta region. And here are some of the photos of that, the product of our collaboration. So in addition to China, we go elsewhere with our partners as well. So in Japan, we have helped our partners at Mitsubishi Fuso, having completed the very first 7.5-ton fuel cell truck, and it's called the Vision F-Cell, which was showcased in 2019. And in Malaysia, we have worked with Chinese local OEM partners to having exported 3 fuel cell buses for the fleet in Malaysia. And for Europe and America, likewise, we work with partners. For Germany, and here are some of the programs that are now coming onto the scene that are called high-bed truck and high-bed buses. These are particularly interesting. They're converted vehicles from internal combustion engine using fuel cell modules to be fully compliant for road use in Germany. And here is the first high-bed bus that was converted and was handed to the customer as of last month. And moving forward, the high-bed truck, 40-tonner trucks are coming on for services very soon. In addition to automotive or transport usage, we're also exploring with partners in Europe for power packs as well as marine usage. For the USA, this is a 63-ton port terminal truck that we have worked with an OEM partner to having delivered to the Port of LA and Long Beach in 2018. So concluding the fuel exemplary cases that we have worked with partners to having delivered and promoting the fuel cell technology, we believe that to truly scale up, we need to work with an even bigger ecosystem, which include energy providers, products, as well as applications. So here are some of our international and domestic partners that we have been working together in order to ensure that hydrogen is a source that are readily available for the customer, as well as producing and designing, producing and manufacturing products that are suited for application use case, as well as together promoting hydrogen technology to find the most suitable applications and to truly get customer buy-in. And it's only through a large partnership, and global one, that we could truly tap into the potential of hydrogen as alternative power for betterment of the society. So moving forward, not only we will be focusing on the transport sector, we're also aiming to go higher, aiming for the sky here on the aviation side, together with partners, and marine, exploring from both small scale to large scale. It will take time, but we believe with partnership, the time will come with fuel cell for marine. And for distributed power for our built environment, fuel cell can be a great supplement to the existing environment that we have. So thank you very much. That concludes my presentation, and I look forward to the panel discussion afterward.
Thank you very much. Now, Mr. Hamamura, Senior General Manager, Fuel Cell Business Field, Toyota Motor Corporation, Chairman of FC Cubic, please. Hello, everyone. My name is Hamamura, responsible for fuel cell development and production in Toyota Motors, and also I'm also chairman of SE Cubic, which does joint research on fuel cells with 30 Japanese companies and universities and technical colleges. Thank you very much for this opportunity today. Now, I would like to talk to you about the acceleration of the expansion of fuel cell technology, which is undertaken by many companies as well as Japan overall. So as you can see on the slide today, I would like to talk about two axes and challenges of Toyota for expansion and also new initiatives to accelerate the spread. And also I would like to talk about the industry, academia, government cooperation here in Japan. So this graph shows the within fuel cells, the technological development in terms of fuel cell power, range, and system cost. So as you can see, we are still in the midst of development in terms of fuel cell technology. So we will continue our efforts in development production so that our products will be helpful to all customers throughout the world. Next slide, please. So this is another initiative. From 2014, we have been developing application together with many colleagues throughout the world who are thinking about the spread of fuel cell technology from trucks, buses, commercial vehicles, and also non-automotive like vessels and trains and stationary power generation can be used for various applications. And we are also thinking of space use as well. So we hope to be able to respond to ever-increasing expectations. However, in terms of deployment of fuel cells in various areas, there are various challenges because the fuel cell systems are made up of multiple components, and also stable output is required regardless of the requirement. It has to be controlled in much detail, and it requires a lot of time because we need to adapt to each adaptation and resources as well. So, for example, in EU ships, we had to do a project of fuel cells within 4 months. And in order to do this in a small period of time, we moduled these systems, and the ship requirements were included in the module ahead of time, so we were able to do this in 2 months. And we learned a lot of lessons. Now, we need to enhance the speed of expansion and also at the same time respond to customer needs. So maybe not a single module, but we should have a series with modules with many characteristics that may be easier to use. So in spring of this year, we used the technology of Mirai, which is the second generation fuel cell vehicle. The vertical, horizontal, and small type, 3 types of output were combined, and we announced the module lineup. It is only 7 months since we have made the announcement, but from throughout the world, trains, large trucks, and also large power generation many applications were able to proceed simultaneously. In Japan, concerning fuel cell initiatives, it is not done by single companies alone, but we are seeing more industry, academia, government collaboration. In Japan, there are facilities that boast of atomic level physical chemistry analysis, and also there's academia with much know-how. Based on the government roadmap, the companies will provide specific issues, and by using high-resolution facilities from various perspectives, universities and technical colleges will carry out analysis. So this is an evaluation platform using all of Japan, so all Japan activities are currently underway. Recently, one phenomenon that could not be developed by one single company due to these initiatives have made clear. So these all Japan activities are moving on to the next phase. So high quality fuel cells need to be created efficiently, so standardization is required. So the definition of standardized stack will enable the entry of various players with many parts like catalysts and separators and sealings in production as well. And it will lead to increased performance and speed. So not only in Japan as well, but by collaborating with other countries, we are having discussions on the standardization of evaluating the efficiency of actual trucks on a very short period of time. So we have introduced various initiatives that we are taking here in Japan as fuel cells, and we hope that this will lead to accelerating the spread of fuel cells throughout the world. Thank you for your attention. Thank you very much. So the next panelist, Dr. Ludwig Christos-san from ZSW.
Good afternoon, good morning, or good day from Germany. I'll try to give you a short introduction into what we consider essential for fuel cell electric mobility. Just let me introduce ZSW in the first place. We are a not-for-profit research organization having about 300 people working on 85% of our budget is contract research with industry and for industry. We're a state organization. We're operating in the south of Germany with laboratories in cities called Ulm and Stuttgart, and we're working in the field of applied research and development in the broadest sense in renewable energies. And so we do have research topics along the critical value chain in the renewable energies, starting from renewable energy harvesting to renewable energy storage and renewable energy provision. Now, what's the motivation for that? Well, the energy system in the past was based on renewables. In the future, it needs to be based on renewables. And in the meantime, we're using fossil fuels, and we are on the pathway to defossilization of the energy system. And so hydrogen that's generated from renewables or hydrogen that's generated from carbon-free sources will become a key element in the energy system of the future, and particularly in decoupling the time and the location of energy harvesting from the time and the location of energy use. And so hydrogen will be a link between the fluctuating renewables to applications that need a more constant and need a more reliable supply of energy. Basically, fuel cell vehicles is one point. They are fulfilling customer requirements. Companies like Toyota are providing excellent vehicles. The endurance for light-duty vehicles is good enough, and they're ideally suited for vehicles with high energy demand and high endurance, like for long-distance travel or for heavy-duty vehicles. The modular approach that has been shown by Toyota is an excellent way to not only to use technology which is developed in a high volume application like the light duty vehicles for various other applications like the forklifts, like heavy duty vehicles, like electricity generation, or even like marine applications. And so Basically, fuel cell powered vehicles, the light and the heavy duty they are fitting well in the transformation of the energy system towards a domination of fluctuating renewables. And so hydrogen will serve as a seasonal buffer in the electricity sector, and it will also serve as a buffer in the transport sector. And a very important part for using fuel cells, using hydrogen technologies in the brave new energy world will be the production and the consumption of hydrogen is completely decoupled in time and in location. So it makes it a strong difference from battery electric mobility and from battery electric use. Seasonal storage and complete decoupling from energy harvesting and energy use. Looking at the infrastructure, there is no such thing as a hydrogen infrastructure, or a large-scale hydrogen infrastructure available today. But if you look at the number of filling stations or high-power filling stations that you need, you're on a, let's say, lesser number in hydrogen than in the pure electric. Fuel cell systems developed for the light-duty market can, with minor modifications, also serve the heavy-duty market. And what needs to be tackled is the high cost, which one thing is to tackle it by mass manufacturing. The other one is to tackle it by a supply chain similar to the one that's established for internal combustion engine driven vehicles these days, where a wide range of supply components are available and a wide range of companies are available to provide high quality products. Standardization and the classification scheme for fuel cell power also will help fuel cells and fuel cell modules into the market. And one key issue also addressed by Hamamura-san is better understanding of the lifetime issues and the factors affecting fuel cell system endurance. So that's a few words that I had to spare. Thank you very much for your attention, and I'm happy to stand for discussion.
Thank you very much. Thank you for introducing the latest trends. Compared to several years ago, the technology has advanced. It's already technology ready, I think. However, still, the market is in the infant stages. It has to be created going forward. So I would like to ask one question to all of you. Now, going forward, the global market, we need to create global market and expand the market. So what would be the key to that? Technological challenges, or maybe there may be various production challenges as well. So the key for that and the approach. Can you give us a comment from each of you? Starting from Tim, please.
Sure, thank you. It's a great question. I think when you think about the expansion that's needed, it really comes down to scale. So not only scale in the fuel cells themselves, but also scale in the rest of the infrastructure. It was mentioned that when you think about the refueling stations and the infrastructure required, that also has to come in addition to low carbon hydrogen or green hydrogen from renewables. That's really key. So when we think about what needs to happen globally, we need the demand, the end-to-end solutions. We also need, from a legislative standpoint and from countries to think about what's required from a decarbonization standpoint and put in the requirements for meeting those requirements as well as incentives to get there. We've seen in the United States that there's been some success or some market expansion projects for fuel cells a few years ago that actually allowed us to deploy several fuel cells to customers and allowed them to get the experience and trial. So further expansion of those types of projects are really, really important. But we believe at Plug that it really requires an end-to-end solution. We really saw the scale up of fuel cells in the material handling business that we have take off when we introduced the full turnkey solution, which included fuel cells, hydrogen, refueling infrastructure, and service. So customers really want an end-to-end solution. They don't want to just get fuel cells. And so it's really important to be able to make that available for customers and also make the rest of the system autonomous for them.
Thank you very much. Richard, please.
Yes, I have to agree and confirm what is presented by Mr. Cortez here. I think that we need to support the customers in transition with end-to-end solutions, helping them to bring down the hurdle or the challenges to address this new technology. With that said, I want to repeat what I mentioned previously, that we need to also see the large-scale industrial platforms where we see trials in large scale, because then you build also the knowledge, because this is a transition into new technology, and every technology shift, I would say that the main competitor is not just us around the table or additional technology. The main competition is the fact that the customer is slightly reluctant to change. They might have a change in operational processes, they might have a change in how they go about their daily business and how they create value, and it is our interest to minimize that change and to just support them continue with what they do. So as was said, end-to-end solutions, but then the large-scale industrial projects, pilots, for us to build end-user knowledge, domain knowledge, and then capitalize on that together, because that will accelerate the whole transition.
Thank you very much. Audrey, please.
Thank you. Well, I couldn't agree with Tim and Richard more on this point. You know, the end-to-end solutions is one that will truly and truly deliver value to the customer. Hydrogen and fuel cell is still at its nascent stage. We need to educate and inform, as well as hold hand of our customers to let them know that this is a friendly technology and it's at a maturity that's ready for deployment, even though at small scale, but we can build the ecosystem together. So minimizing the change for the customer and minimizing the pain for the customer, it's something that we can do together. So be it by providing additional services, be it by building a better comprehensive ecosystem where hydrogen and after-sales services are available as a holistic solution, it's one that's needed by the market at this time. And now with great government support, we're seeing more than 30 countries having their national roadmaps on hydrogen deployment. This is an opportunity for all of us in the industry to really tap into that customer value. And we have to deliver that together. So projects, trial projects or showcase projects, in that case, every one of them is a good one at this time. So we need to treasure those opportunities given by the customer, given by the market, to showcase the technology that we have developed over these years, that this is ready for early adoption. And the second point, I think, to the project trials are the collaborations that we as industry collaborators or industry peers can come together to develop in terms of technology. There will be the next generation of technology that'll be cheaper, it'll be easier to manufacture, ready more easily to scale up. So these are the technologies that perhaps we can identify project opportunities to come together and develop. And the third point on top of the project collaboration is the standardization. Standardization across the globe. What does it look like? We as an industry right now is global, so the standardization of that needs to catch up from a global standpoint as well. And last but not least, I think in order to truly scale up hydrogen, the availability of that and the cost of that need to come down to the parity of diesel, and in some cases as a battery, as electricity, in order to truly be apple to the incumbent technology. So, the gentlemen from Module 1 have done a great job explaining the trend on that, where industry is moving. So together, I think we're in good hands as an industry group for this technology going forward. Thank you.
Thank you. Mr. Hamamura, please. All of your opinions are very informative. So there's just one point I'd like to say. In order to ramp up the market and also for the customers to safely utilize this, I think what is necessary is to have a global, unified way of standards and evaluation of quality and safety. So in that case, the users and the manufacturers will be able to use this safely and securely. So new evaluation method and new standards, it is being used in various areas and it is still under development. So it has to reflect the usage conditions of the users as well as the latest efficient evaluation methods should be incorporated at the same time globally. So as a result of that, the hurdle for new players will go down as well. Thank you. Mr. Ludwig, please.
Yeah, lots has been said in terms of creating an ecosystem, either as an end-to-end solution from one company or as an ecosystem of many companies collaborating and let's say standardization and common interfaces and common understanding on safety and material issues is a key point for further advancement of the technology, as well as it is to collaborate between different sectors of industry and also collaboration of industry and academia. Thank you.
Thank you. So for the expansion of fuel cell modules, there were various ideas. So in order to scale up, and also the users, so how to provide value to users, that is also very important. And in order to make that possible, a global, in terms of quality, evaluation, safety, there has to be a standard, and also transcending sectors, industry, academia, collaboration. I think there are various elements. And also, overall, globally, we need to collaborate in order to proceed. So we hope that there will be new collaboration that will be born. So maybe next year, we will be able to share bigger results. I'm looking forward to that. And next year, not over the web, but I hope to see you in person to have deeper discussions. Now, I think we had a very significant discussion with all of you today. Thank you all very much for participating. I'm looking forward to seeing you again next year. Thank you.
Thank you.
Thank you very much.
Thank you for having us.